Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I will show you how I will do assembly drawing and also exploded view drawing of the Solidworks Frother. Okay, in my previous video, I have shown you how I've done the full assembly of this Frother and also the exploded view of this Frother with the explode lens cast as shown here. Alright, the next move is I have to produce a set of working drawing. A set of working drawing of a product. For an example, this Frother, I need to produce an assembly drawing together with the exploded view drawing and together with the detailed drawing of all the components here, except the standard components like DC motor, the AAA batteries, the tactile switch, the battery connectors, and maybe some other standard parts. Alright, a set of working drawing means that of our product, we must have assembly drawing, we must have exploded view drawing together with the detailed drawing of all the parts except the standard parts. Alright, for this video, I will only show you how I will do the assembly drawing and also the exploded view drawing. Okay, let me show you how I will do this in Solidworks. Okay, before I proceed to assembly drawing and exploded view drawing, okay, if we look in this file here, this is assembly file. Under the feature manager here, we have all the listing of all our components. But when we look at it, the order of this listing is not in order, it's not in hierarchical order. What I mean is not in hierarchical order is that the way the order of this listing here must follow the order how we will do the assembly. Alright, because it will affect our assembly drawing and also exploded view drawing. Because assembly drawing and exploded view drawing, we have balloons and we have bill of material. The balloon is kind like a pointer or labeling, and it will do numbering each component. For example, it will go for component number 1, 2, 3, and so on. But the numbering of that components will depends on this list that we put here. If the list here is show here, the first one is bottom casing, the second it goes jump to the AA batteries. So when I do labeling in assembly drawing and also exploded drawing, it will show, I will do the balloons, it show this one will be number 1, and if I point on this batteries, it jump to component number 2. It's kind like the way the order of numbering is not in order. We have to follow the order. So what I mean is that, okay, since the bottom casing is the base component, bottom casing should be number 1. Okay, the way we arrange how we mounted the component on top of this bottom casing, so we have the group of this DC motor, connector, cap, and also the steering rod. Okay, the way the order we do the assemble, DC motor should be number 2, followed by this connector, the coupler, the cap, and the on the steering rod will be number 5th. Okay, and then followed by these metal connectors will be put into the slot, and then follows by the AAA batteries, and so on and so on. Alright, so let me show you. So I need to rearrange this listing here in order. Okay, since I've mentioned bottom casing is number 1, so bottom casing should be first in the list. It's already here, bottom casing, the first one. But if you look here, straight away, the second one is AA batteries. So I need to rearrange it. As I have mentioned, the DC motor will be the number 2. So here, the DC motor, I will bring it up right after the bottom casing. So now DC motor is number 2. Right after DC motor, I have this connector. So here is flexible coupler. I will bring it up right after the DC motor. So it will be number 3. Then I have cap. So the plastic cap, I bring it up right after the coupler. So it will go for number 4. For number 5 will be the steering rod. So I will bring the steering rod, bring it up right after the plastic cap. So it go number 5. Alright, number 6 will be this battery connectors here. So this one I have the battery connector here. So I bring it up right after steering rod. So it will go number 6. About number 7, I have two batteries here. So I have battery 1 and battery 2. So battery 1 is already right after this battery connector. About the battery 2, I bring it up right after battery 1. Alright. I've kind of like make the arrangement of this bottom casing and all the related components on top this bottom casing. Alright, about this sub-assembly of this opening lid here. Since here I have AAA batteries, right after the second AAA batteries will be the opening lid itself, since the opening lid kind of like the base for this sub-assembly. So I will go this opening lid, I select it and put it right after battery 2. Alright, for this sub-assembly, okay, the first component, the order of how we will do this assembly here. So which I should go for this push button. It will be mounted onto the surface. So right after the opening lid, it will be the push button. I will bring it up right after the opening lid. Okay, after the push button have been mounted here, the order of me doing the assembly is that will be these two batteries connectors. So I have two of them, battery connector single. One is already right after the push button. Battery connector single 2 is right after the number 1. Then after this battery connectors mounted onto the slot, so what I should go is will be this bracket. Alright, this bracket will be right after batteries connector single 2. So right after it will be bracket. Then only I will slot in the tactile switch on top of this slot of this bracket. So the tactile switch is already there. And the last one will be the top casing. Okay, if you see on the list here, the last one is the top casing. Okay, since I've done putting all these components into hierarchical order, now I will show you how I will do assembly drawing and also exploded view drawing. Okay, let me save my file first. Alright, in order for me to do this assembly drawing and exploded view drawing of this make Frother, so I will go here, I will click at this new, I click at this arrow, so then I will go for make drawing from part assembly. Okay, automatically Solidworks will bring me to the drawing mode. As you can see here, it asks for the sheet format size. It means what paper size that we need to produce for the drawing. We have a list here, kind of like a standard size from A0 to A4, either in landscape or in portrait. But actually, I have already done the template for the drawing in A3 size. By the way, you can look at that, the link. I already put the link under description of this video. I have a video where I've already created the template in A3 size with a title block. Okay, you can see the link under description of this video. So I will browse to that template that I've already done. Hold on, so I will go to the folder where I've saved that template. Right, then I click open. Okay, then I click OK. Okay, now, as you can see, it's already there, the template in A3 size. Alright, the first thing to do, since this is the old template that I've done in A3 size, I need to do some editing. Okay, now I'm in drawing mode, but the first thing to do is I need to edit this title block. Since this is the old template that I've done, and as you can see, I have the logo UTM, but the name here is School of Mechanical Engineering. We are no longer School of Mechanical Engineering, is already Faculty of Mechanical Engineering. Okay, to edit this title block, I need to bring my mouse here to the title block and I will right click at it, then I will go edit sheet format. And now the title block turns to blue outline, so it means I'm now editing this title block. Okay, the first thing about here, it's no longer school, so I need to edit. Oh, hold on, I can move the text here. Hold on. So I will edit, I will replace this school to make sure it's in capital letter. Faculty of Mechanical Engineering. And another thing about the title, since this is the old project, Mini Blender, so I will change it to Make Frother. Okay, this would be Make Frother, right? Okay, another thing, since the first drawing I need to show you is about assembly drawing. Assembly drawing is in orthographic, and one of the view could be sectioning view. Maybe it will be on front view and top view, and it is an orthographic projection. So I must have this third angle symbol projection. All right. Another thing is about here, the material. Since assembly is a drawing where we put all the components in together in full assembly, so we have a lot of parts or components. So I don't have to put the material here. Okay, another thing about the drawing number, later I will decide either I want to put this assembly drawing number one or not. So later I will decide. So at the moment I leave it blank. Alright, another thing about this Make Frother project, I found out the exact scale to be full scale. So I will edit this. This is half scale. So I will change it to full scale. So I will make it full scale. Alright. Okay, another thing you have to put your name and which section are you, and maybe your metric number. Okay, now I've done editing this title block. Then I will exit here at the top right. I will exit the edit sheet format, and now I'm back in drawing mode. Okay, now I'm in drawing mode. All right. Okay, I just need to explain a little bit roughly about this interface of this drawing mode in SolidWorks. If you look here, the interface is kind of like different with our SolidWorks assembly mode and also part modeling mode. Alright, the first thing I need to explain is about here, the main important thing is about on the right here, we have the menu here, the settings, we have view palette. Alright, view palette is where it will link with your SolidWorks assembly file, because in our SolidWorks assembly we have projection, front, side view, top view, and so on. Right. Okay, sometimes the interface here about you are not under view palette here, so maybe you are on the, if you look, we have the icon here, the vertical icon, maybe you are on the first icon about 3D experience, and here is about SolidWorks resources, design library, we have the fourth one, file explorer, actually it's the fifth one, it is a main thing, view palette. View palette means it will put the menu on the right here, all your view projection in your SolidWorks assembly file. Okay, let me show you. Because since I want to show you how I will do the assembly drawing, and later the second one will be explore the drawing. So I need the view menu here from my SolidWorks assembly file. Okay, it's not show here. I already in the view palette menu. Okay, here under the list here, so I will go for my SolidWorks assembly. So then automatically SolidWorks will put all the view. Oh, hold on. Okay, I have all the view here that link with your previous here assembly one, SolidWorks assembly. I can drag front view, right view, and so on into this my drawing. Right? Okay, even I can drag the isometric view. Okay, since the first drawing I want to show is about the assembly drawing. Assembly drawing is not isometric projection. Because assembly drawing I need to show this make Frother in maybe two view, maybe front view and plan view. But just need to mention to you, sometimes like this right menu is showing right view. Right view actually is front view in my drawing, because the way I do the modeling, the orientation of my make Frother in my assembly file actually is kind like a right view in SolidWorks read it as a right view. Okay, just let me show you, since I want to do assembly drawing in this SolidWorks drawing. So I will drag, so kind of like we need to plan what view we need to drag into here. So since this is assembly drawing, so I will drag the right view. Okay, I select the right view. I will drag it, bring it here. Actually, this is front view for my assembly drawing. So as you can see, I have already have the right view. And if I bring my mouse here, kind of like it go automatically will do projection for the plan view. I guess I just click it like that, right? If I bring my mouse like this to the right direction, it go for isometric view. And if I bring my mouse here, it go to the side view here. Another this is a left view, this one is a right view. If I bring like this, it go to the bottom view. If I bring to this angle, it go to this orientation of my isometric view. Okay, I just press escape to cancel. I just want these three views. Okay, the first thing I need to explain to you this is important because this is assembly drawing. So the way how you plan to do for your assembly drawing, since for my make Frother case, I want because make Frother is a full assembly in photography. We have, for example, that it is a plan view. So we have a component, some of it is outside that is already shown here, the steering rod. It already shown here there is top casing, but about the bottom casing is behind that, and also the other components like batteries, the DC motor, the connector, and so on, about the bracket of this opening lid and so on is kind of hidden. So it means that you need to plan it. Okay, you need to plan it. Okay, one view will be full section view. It means that this is a top view, this is a top projection. So the bottom one will be my front view since I'm third angle projection. So it means that this top view, I will do a full sectioning, and my front view will be the view that I have a full section, a section view with a section line. So it means that my top view, my top projection, my plan view, I have a full cutting plane, full sectioning, and it means that my front view at the bottom is not like this, it will be in section view. So what I mean here, I will delete it. Okay, I don't want this view because it is not session view, but what I want is just this top view, right? Okay, so I just bring my mouse here. The first thing to do is I click at this view portion here. So I here, if you look on the left here, automatically it goes to the setting. Okay, I don't want to explain in detail. I only explain the important thing. Okay, if you look here on the setting on the left here, it's about the scale. Okay, by default, Solidworks put it 150 scale. That's why when we look at it, the view is so small compared with this A3 size, because Solidworks put it in this 150. So I need to click at this arrow. I will go up there and I will go to full scale mode. So now this is full scale compared with this A3 size paper. Okay, I will bring, so since this is a top view, I will bring this plan view here. And about this small view, this is isometric view. I just bring it there. So this isometric view will be, I put it half scale. All right, half scale. Okay, this isometric view need to be put here, kind of like it helping for the reader to read the drawing beside the full assembly drawing. It's kind of like show what is actually this product all about. It kind of like extra illustration to help people to read our drawing. So here, okay, the first thing to do here, if you look at this outline, we have kind of like extra edge here. I can right click at the viewport and I go for this tangent edge, I go to remove. It means it kind of like show only the outline. Maybe I can show under shaded mode like this, right? But if I go for shadow mode, I couldn't have it still have this outline of my SolidWorks file. Okay, let me go just kind of like, it depends, you can go like this, shaded like this. Let me just really go for this shaded with outline. All right. Okay, about this top view here, I will click at this viewport, then I will right click at it, and tangent edge, I will also go for remove. It means that it will not show kind of the tangent, only show the outline of my this top view, right? Okay, my next move is that I have to do section view at the bottom here, since this is a top view. So the top view, I will do a cutting plate. I will do full sectioning. Alright, since this is the top view, we have a cutting plane. For when we do assembly drawing, we try to avoid any hidden line. For example, I cannot select this view. under display style, if I go for hidden line, so this is not correct in assembly drawing, because assembly drawing we don't have to put hidden lines, because we have to make assembly drawing simple version that the viewer of our drawing can easily understand about our product. So that's the idea. I remove the hidden line, so I just show only the visible line. So that's the idea why I do full sectioning. By doing the full sectioning, I have a cutting plane here. It means at the bottom, I will do section drawing, so it will show all the hidden component inside this big frother. All right, so here I will do sectioning. Okay, to do sectioning, by default, our tab is under notation like this. To do section here under drawing, I have here under submenu above here, we have section view. If I click at section view, if you look at the setting on the left here, so I have option to use section or half section. Okay, for my case, I will not use half sectioning. I will go for section since I will do full sectioning. Okay, if you look the menu bottom here, we have for full sectioning, I can go for vertical, horizontal, I can go for angular sectioning, and also I can go for align sectioning. For this case, I will do straight cutting horizontal, so I will go for the second choice, horizontal full sectioning, then I will bring my mouse snap to that middle point. I just simply click OK. Alright, this thing appear when you do sectioning. It asks about all the component that we need to remove from being hatching in our section view, because that is a component inside this milk frother, like DC motor, like tactile switch, like AAA batteries, and even a rod here. The steering rod, the shaft is also, we must remove that component from the hatching. I mean, we don't do in our section view with the hatching line. Alright, so certain standard component, we need to remove it. Okay, I just remain it like this because I can do this later. I just simply click OK. And now Solidworks put the section view. So I will bring my section view at the bottom here. So this, my front view will be my section view. As you can see here, component like DC motor, because Solidworks cannot figure it out, the DC motor, it hatch. For example, this long rod is also when we do hatching for the shaft, like long rod, it quite kind of like look weird. So I also need to remove them from the hatching. Okay, since the cutting plane is not cutting the AAA batteries, so it's okay, it's not hatching the AAA batteries. But about this metal connector, is kind like a standard component, because metal connector is the battery connector, we don't fabricate it. It means that it's not our custom design. So this is a standard part that we order it. So this metal connectors also need to be removed from being hatching. All right. Alright, about this tactile switch also need to be removed from the hatching. Alright, before I do that here, okay, let me show you a little bit basic about this cutting plane of this sectioning. As you can see here, Solidworks put this cutting plane is kind of like a jotted line, that is hidden line, so this is not a standard format that we will do for our cutting plane for our section view. Alright, I need to change the setting to follow the ISO. Alright, even here I have the E. I cannot put it, normally I will do for capital letter X. Okay, if you look at the setting on the left here, so since here we have, it's labeled E, so I put X, make sure it's capital letter, it's X, so then I click OK. So now, if you look here, my cutting plane is labeled X, and at the bottom here is already put the labeling section XX. Okay, about the scale, I don't have to put scale 1:1, since at this drawing block, we already have scale 1:1. So here I double click at this text here, and I will remove scale 1:1. So I just remain it as section X. Okay, I just bring it a bit lower like this. Hold on. All right. Okay, about this cutting plane, the section line, so I need to change it to follow the ISO format. So to do that, under the tools here, so I will go for under option. Okay, if you look for these settings here, I will not go system option, I will go for document properties. Under the views here, we have section. By the way, your views is not like this. I have to click plus for the views. And under section here, so I will do, because by default, Solidworks go for American National Standard Institution. So I will go for ISO. So it means my cutting line will be center line. So I will use not the third one. I will go the first option. It means that we have standard with connector. It means I have a center line between these two pointing arrow. All right. Another thing about here is the thickness of your section line. Since by default SolidWorks put it, if you look here, the thickness of the section line is kind of like too thick. So I will not go for 0.35. I will go for the second one is 0.25. Then I click OK. And as you can see here now, it changed our cutting line, our section line in center line, line start, right? Okay, another thing about this, I think this, we have an arrow here. I think the extension is kind of like too long here between, for the both left and the right. So I can edit the length. I can edit the section line if I bring my mouse here. So I select it and I will right click the mouse. I click at edit cutting line. So now I can do the setting to edit this cutting line. So here under the edit sketch, I click at it. I will not adding any line because when you do edit line, you can do kind of like offset sectioning. So I just simply press escape. I just simply select this line. I make it a little bit shorter. It's not too much. I don't want the extension of that arrow is too much. So kind of like the arm, I make it shorter like this, right? Then I click OK. Then I exit the sketch. And now our uh, the the extension of this section line is kind of like shorter, right? Okay, I think this is good enough. So let me just save my file as, hold on. I need to save this file as assembly draw. It's already saved is by assembly one SolidWorks draw, right? Okay, uh, previously I've mentioned that I need to change here. Okay, another thing is about, okay, certain component like standard component, we need to remove this component from the hatching. So I simply click my mouse here. So I will right click mouse and I will go for properties. Okay, under the setting here, I will go under section scope here. Okay, under section scope, so I can select any component that I want it to be removed from the hatching. So I already select that DC motor. It's already listed here, so it's stated here DC motor. And another thing about the rod also, when you have a long shaft, you have to remove it. We will not do hatching for the like shaft or rod. So I select this one. So the steering rod already selected. Okay, another thing about standard component, let me bring it this one here. Let me pan. Okay, another component standard, since the battery is not involved in the section plane. Another thing is about, as I mentioned, is these metal connectors. I need to select also the battery connectors because that is a standard component. So it's already listed. And another thing is about, okay, this battery connectors does not involve in sectioning. It's about this tactile switch. So this tactile switch, see already listed here, tactile switch is also listed to be removed from bin hatching. Okay, I just click OK. Okay, now I have all the component that I removed them from bin hatching because that's a standard component. Okay, it looks better if you look at this long rod without sectioning, right? Okay, okay, let me save my file again. Okay, my next move is that if you look at this, the way SolidWorks put the hatching line for this component, top casing, bottom casing, and all the other component, it's kind of like the way SolidWorks put the hatching line. Every component have the same angle, and even the the density of this hatching line is too close. I need to make this density of this hatching line a little bit finer than this. Alright, the rule of section is that when the component next to each other, we have to make the angle of the hatching line will be at a different angle to avoid confusion. Alright, so I will change the settings. Okay, to do that, I will select this hatching line of this top casing. If you look the setting on the left here, by default, material check at the material cross hatch. That's why the appear is like this. Okay, I will uncheck this material cross hatch. It means I want to do the most basic way. So I have here option I'm using hatching. Okay, I have the list here, what material I want to choose. So I will do the most basic way. So I will go for parallel lines. Okay, as you can see, Solidworks make a parallel line for this hatching line. So I don't want to be, the degree is horizontal. If you look under parallel line, below here we have kind of like the degree of the density of our hatching line. One means it means that maybe per inch, and SolidWorks will do one hatching line. If I increase the value kind of like 3. If I go for 3, it means that SolidWorks will go for per inch. I have 3 hatching line. But I don't want to go for horizontal. Below here, I can play with the angle. I go for 45 degree. Okay, now SolidWorks make it more dense with 45-degree hatching line. Okay, about this plastic caps, since the rule of sectioning, the component next to each other have to make different angles. So I will select this hatching line of the plastic cap, and also I will hold down my control key, this one, and uncheck the material crosshatch. So I will go for parallel lines. I will go for 3, the density, and I also go for angle is reverse negative 45. Right. All right. The bottom casing is next to this plastic cap. So here I select this bottom casing. I will uncheck the material crosshatch. I will go for parallel lines. Then degree is 3. Then angle for this one is 45. All right. The rule is that next to each other we cannot share different component next to each other. Two different component have to be different angle. Okay, another thing about this plastic, about this coupler here, so I will select this one. Okay, this one I can remake it as 45 degree. Okay, uncheck the metal crosshatch, then I will go for parallel lines, and density is 3, and I will go for 45. Okay, this one is okay. And about, if you, okay, I don't have this thing for at the back here, right? At the back here, I have this, okay, this is a zone. This is the opening lid sectioning. So I will select this, hold on my control to select this one also. This opening lid, so it cannot share the same angle with the top casing. So I will uncheck the material crosshatch, then parallel lines, density 3, and I will go for negative 45. So it means that opening lid have different angle. Okay, about the plastic cap, sorry, about the push button. Yeah. Okay, about the push button, I will go 45, but I use the parallel lines. Right? Okay, 3, and I go for 45. Okay, I believe that's all for the section line of this section view. Let me check. Yeah, I think that's all for the component. Okay, I click OK. Okay, I save my file. All right, the next thing is that if you look this is a long rod, and this is a cylindrical of the AAA batteries. So I think I need to put a axis line, center line here. Better to have a center line, axis line, rather than we don't have one. Okay, so to put the center line of this long rod here, under the annotation we have center line. So I will click at these two lines of this rod. So I have the center line there, and also for this battery, I will select these two lines. So I have the line there. Then I click OK. Okay, for this line, I can adjust it. Put it like this. Okay, to show that it is cylindrical. Okay, better to have one for the center line. Okay, I save my file. Alright, the next thing to do is that since I've completed this top view with the section line, and this front view is a section view with the hatching lines for all the components. Alright, the next thing to do is about bill of material and also the balloons. Because in assembly drawing and also explorer drawing, we must provide the balloons and bill of material. Okay, I will go for bill of material first. Okay, to do bill of material, if you look SolidWorks under the annotation here, under the submenu above, we have tables. So I will click at this arrow, then I will go for bill of material. All right, so here, if you look the setting on the left, SolidWorks is asked to select any view that it can detect all the components. So I will go this front section view. I will bring my mouse and click at this viewport. Then if you look the setting on the left here, okay, the first thing about here, the bill of material, SolidWorks asks for the table template. Similar like this title block, I have already done the template title block, but this one is about template for bill of material, the table. If you have kind like have done a template for table or BOM, so you can browse it through this button. But for this case, I have not made yet any template for BOM, so I just will use the standard BOM. All right, I just click OK first, then here SolidWorks will put the standard BOM template here. Then I will make sure that I snap at this lower right corner. Snap at this above this title block. Okay, as you can see here, there is a table. Okay, another thing, but if I select this table here, if I select this table and the setting on the left here, I don't want to explain detail, just I explain the important thing that you should know. Okay, if I scroll to the bottom here, if you look the text format, I must click at all uppercase because in for BOM, all the text must be in capital letter. I check at all uppercase, then I click OK. As you can see now, the table have capital letter. Make sure that this table is kind of like snapping here. Right? Okay, if you look in this bill of material, okay, the way SolidWorks put the standard BOM here, the way the column that SolidWorks put is, the first column is item number, and the second is part number, third is description and quantity. It's kind of like, it's not right. I will change here later. It's about number. This is supposed to be name of the component, not part number. The third one supposed to be material. Fourth column is quantity, and I will add another column here. It's about drawing number. Later I will show you how I will do this. All right. Before I do that, let me explain to you here about the number of the component. As you can see here, SolidWorks have already detected bottom casing is number 1, DC motor is 2, 3 flexible coupler, and so on, up until the last one, the top casing is 40. Okay, if you remember earlier in this video, I have already explained to you how I do rearrange of my component in my assembly file in order based on hierarchical order. I have arranged this kind of arrangement since why the bottom casing is supposed to be number 1, since bottom casing is our base component. Then we will mount the motor, then we will mount the flexible coupler, plastic bag, steering rod, and so on until the last component will be the top casing we mount to close to make a full assembly. So I have already rearranged this component in order if you look in my earlier of this video. So that's why that is very important. Now automatically in BOM, so SolidWorks will put the number here based on that hierarchical order. So that's why it's very important. Okay, another thing to mention to you is that the way I show you how to do this BOM in SolidWorks is the most basic way. Maybe you can find in YouTube, there's a lot of video there, how we can do BOM in SolidWorks more efficient, because there is a way to do BOM more efficient by kind like they have dynamic link with the part modeling file of each component, like you can automatically detect the material, the name, and so on by doing the configuration and properties of each part modeling file. So the one that I explained to you is just the basic way, right? Alright, another thing, if you look here, the way SolidWorks put the bill of material, the header name is not right. I will change it. I will show you this number. This is not part name. This is supposed to be name. This is supposed to be material, and this is quantity. And I will add another column here, drawing number. Alright, one more thing that I need to explain you, the way the name of your each component here, for example, like this bottom casing, it depends on how you name your part modeling file. Make sure that when you name your part modeling file, you name it properly. Okay, by the way, you can double click at this and you can rename it your own. Okay, but it's not advisable to do that. Alright, I just need to do some editing here because I need to change this one. If I double click at this header name, I can change it to this one supposed to be number, and this one supposed to be name, and this is material, right? And this quantity I already have. I will add another column. Before I go for that, about this is my old file kind I already show polyethylene. Okay, actually for the make frother, all the plastic component, okay, we need to put material for the non-standard part. For example, like bottom casing is our own design. DC motor, we don't have material because DC motor is a standard component. We just order it to be assembled in our product. Flexible coupler, yes, is our design, so I have to put material. Plastic cap, I have to put material. Steering rod, yeah, I will put material as metal. Battery connector is standard part. I don't put material for standard part. AA batteries, no material because that is standard part. Opening lid is also is non-standard. It means it's our own design, so I will put material. Same goes push button is our own design. We should put material. All the standard part like battery connector, single one, single two, and tactile switch. We don't tactile switch here. We don't put material. Except the tactile switch bracket is our own design. Is a plastic component, and same goes for top casing plastic component. Right, I just put here because this is my old BOM material. I put it as polyethylene, but actually you can look, search through internet what is the proper plastic material that you can put here. All right, you can just double click, put a material name here. Just I simply guess this is polyethylene, but I don't think so because we have a lot type of plastic material for casing or for push button. It could be polyethylene, it could be polycarbonate, it could be ABS and so on. So to make this video simpler, yes, I put it. Later I will pause this video. I do have, after I've done some editing, then I will put the material as just a typical plastic material. Okay, before I do that, another thing to mention, you can, this is kind like, you can edit this table. For example, like if you look the row height, the width of this, I can make the width. If I double click, if I click at this table, I can increase the width. I don't want it to be in double lines here. Make sure it's single line like this. And also I can change, if I select this column and hold on my shift button up until here, similar like Microsoft Excel, you can change format row height. I can go for 7. Okay, I can go for 7 like this. And all right, and another thing is about hold on. Okay, I need to show you how I will do add another column here. I will select this column, I will right click at it, and I will go insert column right. So we have another column here, and the name of that column is, the header name is drawing number. You have to put drawing number, right? Drawing number. Okay, I think I have mentioned to you, Solidworks automatically detect all these AA batteries. We have 2 of the batteries in our assembly, so automatically it will be detected as 2. The rest of the component is just 1, right? Okay, I will pause this video because this video is taking too long, and I will resume back after I have done editing this bill of material. All right. Okay, now I resume to the position where I've done editing. As you can see here, for this BOM, I already replaced as general material plastic. By the way, it's better if you can do research from internet, maybe from ChatGPT, you can select the appropriate. For the first level of this drawing, just I remade it as a general plastic. Bottom casing is our own design plastic. Flexible coupler plastic. Plastic cap is our own design plastic. And the steering rod is also our own design, is metal. I just put as a general material. Battery connector is a standard part. I don't put material. AA battery standard part. I don't put material. And opening lid, yes, that is our design. Plastic push button is our design. Plastic battery connector single one and single two is a standard material. No material for them. And the tactile switch bracket is our own design. It's plastic. Tactile switch is a standard part, no material. Top casing is our own design plastic. So I just put as a general like this for the material, correct? Okay, for the last column, if you look at the drawing number, so later I will show you, since a set of working drawing, we have assembly drawing, explorer drawing, followed by this all set of detailed drawing of each component. So bottom casing will be drawing number one. Since this video, I only show you about assembly drawing, and maybe the second part will show about explorer drawing. All right. So it will not drawing number only start for the each detailed drawing of each component. Okay. Since I don't have to put drawing number here for the assembly drawing and also exploded view drawing. Right, so the next thing to do is that I will show you how I will do, since I already have BOM, and how I will do balloons. Okay, before I show you how I will do balloons for this assembly drawing, I found out that if in the Solidworks assembly file, let me go back to my original Solidworks assembly file. Alright, this is my Solidworks assembly file. We are now under configuration tab. Okay, I found that if you have two set of exploded view, now is exploded view 2. This is what I want. But the old one here, if you have two set here, you need to delete one. I found that when you have double exploded view here, and you do drawing, it kind of you will have conflicts in terms of numbering the balloons. So I right click at this exploded view one, this exploded view, I don't want it, I will delete it, right? So I just want the exploded view 2 here. So I save my file. All right, then I will go back to the my drawing. Okay, to do balloons in SolidWorks, okay, I will go under notation here, the menu above, we have balloon. I don't want to go for auto balloon. Auto balloon, you can you just go for auto balloon, you select the any viewport, it will automatically put the balloons. But you kind of like do not in order, you kind of like put it in random position. Okay, for this video, I just show you how to do manual balloons. So I just click at balloon. Okay, the way we put balloon based on this BOM, because number one is bottom casing. For bottom casing, I will not go for top view because top view here is clearly shown this is our top casing. Okay, for bottom casing, I should go for the section view. So that's the idea of section view. So it means that we can point out the internal component here. So bottom casing, I will go for this, the section view. Okay, sometimes your pointer of your balloon is arrowhead. Make sure you zoom it a little bit. I want it to be in solid dot. Okay, I will go for here. There is one position of my balloon, and number two will be the C motor. So I will select like this. Okay, as you can see, it's kind of like we have yellow line to maintain in line. The position of balloon number two is in line with number one. In terms of for neatness, better to make it in line. Number three is flexible coupler. I will select like this. Which way is dot? This one I can go up here. Number three, and number four is the plastic cap. This plastic, this plastic cap. Make sure that do not make your balloons crisscross like this. Make sure it's kind in for neatness. Make it kind of like parallel and in line. This so this will be number four, and number five is the steering rod. Zoom it a little bit, kind of like we have dot like this, and make it kind of like parallel. Okay, there is five. And number six is the battery connectors. I can zoom it like this. So this is the battery connector. So this is six. Make sure that's in line with these balloons 3 and 4. We have the yellow line to make sure in line. Okay, bot number 7 is AA batteries. I can go like this and kind of like parallel the way the direction of the balloons is parallel. Not this is not parallel. Go like this parallel, and it's in line, right? Okay, let me save my. Okay, let me click OK first, and I save my file first. Okay, about component number 8, open the lid and all the component attached to the open lid. I cannot put the balloons here because it's kind of like hard for me to point which is which. It's kind of like difficult to put it, the location of the balloons here. So I need to do something about this view. But since this view, we don't have any, we cannot see any internal part here. what I can do is I will do a broken out section. Remember, we have broken out section. I can create the sketch here, kind of like I will create a portion for me to do the broken out, so that when we have broken up section, we can see the internal parts. All right. To do broken up section here, if you look under the not under notation under the drawing, so we have. I'm not using section view. I will do broken out section. When I click at broken up section, so I will create the outline of my broken out sketch like this. I create kind of a region for me to do broken out sectioning for this portion. So I will go kind of like this. Right. Okay, it will ask any component that we need to remove from B hash. Okay, I will do that. Let us simply click OK. Okay, if you look on the left here, we have the setting here. Okay, the blue area is asking about the direction. I just remain like that because we are looking from the top view. And bottom here, I click at preview and we can see the preview of our broken out section. Here, the above is about the depth. If I go increase it to 15, so we go much deeper sectioning. Okay, I just go for 15. Let me click OK first. Okay, as you can see, we can see the internal parts. So easy for us to do balloons to point the component, right? But here, since we have, I have to do setting here in terms of, because this is AAA batteries, I need this AAA battery to be removed from the set, from bin hatching, because it is a standard component. Same goes for the battery connectors and also the tactile switch. So I need to remove them from being hatched, right? Okay, to do that, okay, now if you look at the left here, we are at the drawing view tool. So I go for broken out section, I right click edit and I go for properties. So this appears, so I will go for tab section scope, then I will zoom, I will select which component I want to remove to be for bin hatch, from bin hatching, right? I select the batteries, so it's already listed here. I select the second battery is listed here. And I select another standard component to be removed from bin hatching is these battery connectors. So it listed there, and also these battery connectors, this one. As you can see, it hatched these battery connectors. Since battery connectors is a standard component, I select this one. So I have these two battery connectors, and also the last one will be this is the tactile switch. I select the tactile switch, so already selected here, then I click OK. And now my hatching of this broken out session only hash the non-standard part. Okay, I still need to do editing here in terms of the, okay, this is part of the top casing. So I click at the hatching. I go for uncheck the material cross hatch. So I go for parallel lines, and about the 3 is the density. And it goes, since D is 0 degree, I will go for 45. And for this one, this is part of the opening lead. I will check here. Three, negative 45. Okay. Okay, about the push button. 3. Then I go for 45. And also we have this, alright, this is part of the opening lid and this bracket to support the tactile switch. So I will go for different angle. So this one will be 45 degree. Okay, component next to each other, different component have to be different angle. So now I have done the setting for this broken out section. Okay, now I will continue the balloons. Since we stop up until 7, so I will go the balloons under annotation here. We have balloons, so I will point up to this. This is the opening lid. Then we have component number 8 for opening lid. Then after 8, we have push button. Then I will go here. So easy, since we have the broken up section, it's easy for us to point the component. So this would be number 9, the push button, and number 10 is battery connector, single one. So I will go point like this, and I will go here. So we make sure it's inline. So this 11 is okay. This 11, the bottom one is 10. So I will go like this. So I will bring it here. So that is 10. And okay, 8, 9, 11, 8, 9, 10, 11. The 12 is the tactile switch bracket, like this. Okay, but the bracket I can put it. Okay, sometimes in terms of neatness, the way how you put the arrangement of your. Okay, I can do it like this for the bracket. Okay, make sure it's inline. Okay, there is number 12, and number 13 is the tactile switch. Okay, the tactile switch is here. Make sure I zoom it. So this is a tactile switch. I can go for like this. Right, so the way how you arrange your I can edit this, make it kind of, we have better arrangement. Okay, so that's all right. I think about balloons, that's all about balloons for this assembly drawing. So I just double check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I missed one part. The last one is the top casing. Okay, the top casing balloons. I can point it here. This way is in line. So this is 40. Right, I have all the components there from 1 up until 14. Okay, let me save my file. And okay, here I already have the title block already been named assembly drawing, and I don't put drawing number for this. So I believe that's all for the exporter drawing. I hope you understand. I'm sorry this video is taking too long, but please appreciate you learn a lot of lesson from this video. Alright, later I will show you, not in this video because this video is taking too long. My second part will be the exploded view drawing. Okay, thanks for watching this video. Inshallah, I will see you in the next video. But before that, please do not forget to click subscribe and like my channel. Assalamualaikum warahmatullahi.